Today's lesson is 2.2 Isotopes, Abundance, and Average Atomic Mass. Today's lesson, we are going to look at isotopes and average atomic mass. The mass of one atom of carbon-12 is 12 U units, or atomic mass units. Understand that when we write an element with that dash and that number, this number represents the atomic mass of that element. Okay, so this is what's referred to as isotope form. So all atoms in a given element do not have the same number of neutrons, so they do not have the same mass, right? So when we looked at mass, and understand that the mass is a combination of protons plus neutrons. So combine those two together and you get the mass. Now, you could have different number of neutrons, which will result in a different mass altogether. Hence, what makes these different isotopes of a specific element. So, for example, magnesium here, okay, contains 3 naturally occurring isotopes. So magnesium 24, so the molar mass of magnesium, or 24%. So let's take, for example, this supplement of magnesium that supports bone and muscle heart health. That 79% of the magnesium in this bottle contains contains an atomic mass of about 24. 10% contains a slightly heavier version of magnesium with an additional neutron in its nucleus. Same number of protons, though. Remember, the proton count, that never changes. The neutrons can. And then 11%, an even heavier atomic mass of magnesium. Hence the reason why we've got 3 different isotopes. So regardless of whether the magnesium is found in salt water or magnesium is found in the supplement, just magnesium in general is found at these percentages throughout nature. Okay, so anytime you come across magnesium, understand, and if you remember it, great, it's all just trivial, that 79% of the magnesium in nature is comprised of this specific isotope. 10% of this specific isotope and 11% of magnesium is made up of magnesium 26. So these isotopes are present in elements are called isotopic abundance. So these percentages are also known as isotopic abundances. And so these percentages can be written, and when we do the calculations, will be put as decimals. So when chemists consider the mass of a sample containing billions of atoms, they must take the isotopic abundance into account. So the average atomic mass of an element is the average of the masses of all the elements' isotopes. Okay, so if you look at that magnesium one, the average atomic mass that you see on the periodic table is based on the fact that we have these percentages of these isotopes that are actually naturally occurring in nature. So carbon is made up of several isotopes, not just the carbon-12. Carbon is made up of 3 naturally occurring isotopes. So the carbon-12 that we know of, there's a carbon-13, but there's a very little percentage. So if we think about carbon dioxide in the atmosphere, 98.9% of the carbon in carbon dioxide, or the carbon found in glucose, because remember, glucose right? C6H12O6, that 98.9% of this carbon is actually made up of this specific isotope. 1.1% is made up of an isotope of carbon that contains one additional neutron. And a really tiny percentage is made up of of carbon that contains two additional neutrons in comparison to that carbon isotope in nature. So it's a really tiny percentage, but the majority of the carbon in our atmosphere, in the glucose, in any carbon-based compound, is made up of this carbon-12 isotope. So how do chemists find the mass of each isotope? Well, they'll use something called a mass spectrometer. And here's an example of a mass spectrometer reading. And here's the reading for that of glucose. Okay, so the mass spectrometer, very powerful instrument that generates a magnetic field to obtain data about the mass and abundance of atoms and molecules. You can use the data obtained with the mass spectrometer to calculate the average atomic mass given in a periodic table. But understand also, if you have a detailed periodic table, that the average atomic mass is the atomic mass of the element on the periodic table, and you'll see it's a large decimal value. So as we get to the end, we are getting to the calculations involved with calculating average atomic mass, or calculating the mass of a specific isotope. So when calculating isotopic abundance questions, you're going to use this equation here. Okay, so AAM represents the average atomic mass. So you have the percentage, right, which you will convert to a decimal, multiplied by the mass of one of the isotopes. Okay, that might be a given, or that might be something you're going to be asked to find. You're going to add it to the percentage of a second isotope, and then you're going to add it to the percentage of a third isotope, and you're going to keep adding it to, depending on how many naturally occurring isotopes there are for a given element, and that will be detailed in a question. Okay, I think all my sample problems that I'm going to share in a moment contain only two isotopes, so the equation will stop here. Okay, so AAM, the average atomic mass, the percent represents the isotopic abundance of a particular isotope. And understand that the mass of the specific isotopes is given U units, or in some cases, depending on your resource online, AMU units. So here are three sample problems that I have at the end of my Google Slides. So please take a moment and try solving these three questions. In my next video, I am going to outline the detailed answers on how these are going to be answered. However, if you do access my Google Doc or my Google Slide, you will find these detailed answers there to view on your own if you wish to not listen to my taking up of these problems. I hope you liked this video. If you did, do not be shy to hit that thumbs up button. And while you're clicking the thumbs up, click on that subscribe to stay tuned to my new videos. Thanks for watching.